How can we secure a sustainable feedstock supply, both from imports and domestically, without compromising food security? How can the industry ensure there is up-to-date sustainability criteria for biomass across all sectors, and GHG emissions, air pollution, and biodiversity loss are mitigated at all costs? And panelists will explore how innovations in biomass can enable the decarbonisation of industry while examining the measures required so its success at scale does not come at the expense of sustainability. So please welcome to the stage Jaimesh Patel, CEO of Biofuel Evolution, as the moderator. Charlotte Powell, Head of Bioenergy and Carbon Removals, Department for Energy Security and Net Zero. Gordon Murray, Executive Director, Wood Pellet Association of Canada. And Jamie Lewis, CEO and co-founder of Rare Earth Global. For my part, I thank you for your attention. I will be giving the chair to somebody else after this. And please enjoy the rest of the afternoon. Take it away.
Thank you ever so much. Hi, everyone. It's a pleasure to be here, and thank you ever so much for joining the Advancing Sustainable Bioenergy for a Net Zero Future session.
Good afternoon, everyone. My name's Jamie Lewis. I'm the CEO of Rare Earth Global. Rare Earth Global was set up to support companies on their journey towards net zero. We do that by establishing and scaling supply chains of industrial hemp specifically in order to develop ingredients that a lot of the large corporations around the world can utilize going forwards to replace some of the most harmful ingredients that they're currently already using today, such as fossil fuels or deforestation-linked soy. So we try and localize supply chains on behalf of these corporations, supplying products and sort of going a step further than that by also developing methodologies to remove carbon dioxide from the atmosphere and sequester that CO2 away. Because what we found is that companies really need both new products to rely on as well as direct carbon dioxide removal in order to really move the needle with regards to net zero and achieving those targets. Our role in the supply chain is to essentially run it and focus on product innovation so that we develop products that these companies can utilize going forwards.
Thank you, Jamie. Gordon?
Hi, everybody. I'm Gordon Murray. I'm the Executive Director of the Wood Pellet Association of Canada. So we're the trade association for Canada's wood pellet industry. And collectively, we export around 3.5 million tons per year of wood pellets around the world. They're primarily used to displace coal in electric power plants. Some of our product comes here to the United Kingdom. We've got a couple of customers that I think are well known, Drax and Linemouth Power. Our members are also keenly involved in development and commercialization of bioenergy carbon capture and storage. Personally, I've worked in forestry and sustainable forest management for 48 years now. I've got a degree in forestry, worked in all aspects of forestry and bioenergy for the last 16 years. So I'm well acquainted with what goes on in Canada. You brought up the Panorama. I'll be more than happy to address the Panorama program if that discussion comes up.
Excellent. Charlie?
Okay. I'm Charlie Powell. I work for the Department of Energy Security and Net Zero, and specifically I'm head of bioenergy and carbon removals. So I have a really great job, actually. I get to spend a lot of money on innovation and working under the Net Zero Innovation Portfolio, the £1 billion investment into a load of new technologies. but I get to, I'm developing 3 particular areas within the whole biomass, bioenergy value chain. I lead a program called Biomass Feedstocks, so that's looking again at the primary sources of biomass, but I'm also looking at how we generate hydrogen from bioenergy and biomass. So that's quite a little bit, you know, more on that sort of cutting edge journey. And then looking at the carbon capture element. So not only is biomass a really important part of that energy transition to take us away from the fossil fuels, obviously, but it's also unique in that it offers us that carbon capture element. So negative emission energy, negative emission hydrogen, and as well as, you know, if you take it beyond energy, it also has a multitude of different products that's also really exciting with the biomass journey.
Genuinely is, yeah. Thank you ever so much, Charlie. And myself, last but not least, I'm the CEO of Biofuel Evolution. I'm Jamish Patel, CEO of Biofuel Evolution. We're on a mission to fuel a circular bioeconomy by transforming waste materials into valuable and sustainable resources for all, using proprietary bugs and bacteria. So without further ado, we'll get into the discussion topics. The first one, what really makes the bioenergy industry or sector such an integral or fundamental part of the UK energy mix, and how or what does a sustainable biomass and bioenergy sector look like? So just digressing on or following on from the UK government's biomass strategy in 2023. So what are the methodologies or processes and systems in how we can truly achieve a net zero future using bioenergy and biomass? So I'm not sure. Jamie, did you want to?
Yeah, sure. I'd be happy to dive into that. So bioenergy is obviously a critical portion of the government's net zero strategy, as is the biomass strategy document that came out last August. Reason being is because, you know, some of the largest contributors to our energy grid here in the UK have moved from coal to bioenergy feedstocks. And essentially the strategy document that came out not so long ago is the government's effort to articulate the role of feedstocks and biomass in achieving net zero goals. I think biomass is ultimately incredibly critical to the whole strategy because it provides great greenhouse gas emissions abatement potential, so the reduction of greenhouse gas emissions, which is really fundamental. In terms of the actual strategy or where we're at today, the document came out last year that was very comprehensive. It really, I think, goes a long way to sort of plotting a path forwards for various stakeholders across the bioeconomy and specifically the bioenergy sector. Overall, it's been very, very well received. I think if I was to say anything about, you know, what could be done better or what could be worked on going forwards, it would absolutely probably be, you know, more specific and actionable steps. So talking from the perspective of industrial hemp, which is my area of sort of specialist knowledge, you know, industrial hemp is one of those crops that, you know, is probably one of the most promising climate change solutions out there. That's not just to do with the fact that it's great at sequestering carbon. In fact, it's up to 4 times more effective and efficient at removing CO2 than planting trees. Alongside that, it sort of aligns with nearly every single UN Sustainability Development Goal. So the biomass strategy, where it stands today, it sort of highlights that hemp has a great role to play, but perhaps what it doesn't do is sort of go to that extra step of saying, well, how are we going to support this new crop? Because the reality is that there's only 750 hectares of industrial hemp being grown. And, you know, we need to probably shift that or scale that to about, well, hundreds of thousands of hectares over the coming years, not just hemp, but other crops as well. So I think, you know, as I said, more actionable sort of advice or support around direct subsidies towards novel feedstocks would be really, really beneficial, because when you are, and I can say this because my day-to-day is spent sort of focusing on how we really sort of scale this supply chain, and what it really comes down to is risk. How do you organize the risk in a new supply chain? And I think what the government would benefit from is taking more of a holistic approach, looking at the full value chain. So that would include the sustainable producers of that material, the farmers, all the way through to how we work with those materials at the end of life. And by doing so, it's going to really, I think, support companies like ours, stakeholders across the supply chain, and ultimately also ensure that we get the best environmental outcomes from these efforts.
Gordon, conversely on the
Sure.
wood pellet side.
I could make a few comments. I'd just like to say, globally, our whole effort has to be to try to phase out the use of fossil fuels. And, we need all kinds of sustainable energy, renewable energy. We need wind, solar, hydrogen production, we need battery storage, and we need bioenergy. If you look at reports by the International Energy Agency, there's no path to net zero that doesn't include biomass. And currently, globally, biomass accounts for 55% of renewable energy. Many people don't realize that here in the UK, that 11% of the electricity that you consume comes from bioenergy. So the key thing about bioenergy is it relies on the carbon cycle. So the fuel that is emitted, it releases CO2. It's recaptured through photosynthesis when the plants regrow, and it's a continuous cycle. And we have to make sure that we do that efficiently. We minimize the use of fossil fuels along the supply chain. And most importantly, bioenergy is the only form of renewable energy that actually has the potential to draw carbon out of the atmosphere through bioenergy carbon capture and storage, which is just on the cusp of being commercialized at large scale, with UK companies here at the lead globally.
Okay. So from our part, from the biomass strategy ties in very much with the net zero strategy. It does, as my co-panelists here say, has a really significant part to play in achieving net zero in the UK. It is obviously together with all the other technologies that are involved there, but the other key point with the biomass strategy is the sustainability and really emphasizing that it must be sustainable. I'd like to think that we've learned in the UK, certainly with the Industrial Revolution that took away most of the trees in the 18th and 19th centuries, that's no way to go, really, is it? So that sustainability factor is absolutely underpinning what we need out of the biomass strategy at this stage. But it also ties in with, the uses. So the biomass it gives the priority uses. It has a few directions, making assumptions on whether we can have high biomass supply in the UK, whether we have high electricity generation supply. And it sort of does give, as you say, that direction of travel, but not with the full policies underpinning it. So it's showing, okay, this is what we're thinking. We're thinking one of the primary opportunities for biomass is hydrogen generation, which was probably a bit of a surprise to people because with the other renewables coming very much online for electricity generation. So, okay, what is that direction of travel? And the other key part is obviously the greenhouse gas removal opportunity, which for the next 10 years, so with all the ambitions on greenhouse gas removals to 2035, it's really underpinned by that biomass and bioenergy supply. And I think those are really important things to see on that full value chain opportunity there.
Of course, yeah. Thank you. So I want to get these statistics right because it's a government strategy. So according to the strategy, in 2022, 66% of biomass feedstocks were used in renewable energy supply in the UK from domestic sources. And around 19% of domestic feedstock supply was made up of biogenic residues and waste. So that encompasses waste wood, sewage gas, landfill gas, and food waste. And I want to elaborate further on a domestic and international feedstock, more debate, I guess, or conversation. So how can we how can the UK increase the supply of its biomass without causing detrimental effects on the biodiversity, climate, so greenhouse gas emissions, air pollution, water pollution, and also the land use and the resource-intensive aspects to cultivating biomass?
So I think whenever one looks at the bioeconomy in general, you always ultimately have to focus on, producing materials that go to the highest value output to begin with. And then the idea is that you have a cascading sort of effect whereby, residues and residuals are then utilized in a circular fashion and continue to be, adopted and essentially recycled. Talking from the perspective of a novel feedstock, which industrial hemp is, we as a team at Rare Earth have really sort of tried to balance things as best as we can. So at our inception as a company, which was just over sort of a few years ago now, we thought, what is the most critical element that we could be looking at, and that's food. Really, it's the food space, and with that in mind, what we've done is we've looked to unpack value from this crop, beginning with its protein, which you find within the seed of the industrial hemp crop. It's a complete protein, which isn't very common within the plant kingdom. We've been developing and optimizing the protein extraction and refinement, and then looking at, what else can we do with the residuals of our crop. So we look at a combination of supplying ingredients to both the construction sector as well as the bioenergy sector. So these are low carbon ingredients that, as I said earlier, are replacing a lot of things that are used today that are, really quite harmful. I think what differentiates hemp as a feedstock is that it's a very low input crop. So what you have is a 4-month growth cycle. You have an opportunity to develop, products for all these different areas, and you have a crop that doesn't require pesticides. Far fewer resources, shall we say, such as water and fertilizer. And that's really got very little to do with companies like ours, and more to do with, the natural qualities that exist within certain feedstocks that, allow them to be perhaps more resilient, hardier, to be grown more widely. And it's about our ability to be able to understand, what is it that makes sense in specific scenarios, and then really, organizing the support to be able to deliver those solutions at scale. So apologies if it's a bit one-sided. I'm just talking about industrial hemp, but really for us, that is, one of the most exciting solutions available, and one that, we're keen to really push on with and unpack as a real sort of, low GHG and low resource solution to, a multitude of problems that need to be overcome.
Thank you, Jamie. And I'll have to ask you for some supply of hemp protein at some point.
Sure.
Gordon, it would be great to get your perspective.
Sure. I mean, in order to ensure that what we're doing is sustainable, I can talk about biomass that's just, sourced from forests, and the government and society has to be satisfied that if forests are being used for bioenergy, that they come from sustainably managed forests, that once forests are harvested, that they're promptly reforested and tended, that any forest products that come out of the forest go to the highest and best use. We call that the cascading principle, so that we're not burning logs that could be used to make valuable lumber and making energy out of it. That would be preposterous. That bioenergy should come from just the lowest value, the waste, the sawdust, tops and branches and crooked wood that's left behind in the forest. In Canada, only around 4% of the wood that's harvested ends up in pellets, and all of that comes in the form of that kind of leftover material that I was talking about. And in Canada, we're the third largest forest area in the world, 348 million hectares. It's strong laws and regulations governing it, supported by monitoring and on-the-ground enforcement by government. There's no harvesting allowed anywhere without sustainable forest management plans approved by the government. And so we've got a strong culture of caring for forests. I can say in Canada, ever since our country was first settled by Europeans back in the 1600s, we still, even with all the cities and farms and everything that have been built, we still have 91% of our original forests, and we have a 0% deforestation rate in Canada. So we've And in addition to that, we've got more third-party certified forest in Canada than any other country in the world. In fact, we have almost half of all the world's certified forests in Canada.
Okay, amazing.
Okay.
And sorry.
Yeah, sorry.
I do want to move on to the next.
Yeah, no, definitely.
There is a question in here that I'll come to the questions towards the end, and I know everyone's put yourselves as an anonymous, which is a shame, but on that tangent in terms of reforestation and deforestation, there's a question from an audience member. When there is a drive for reforestation from a carbon or flood alleviation and biodiversity perspective, is it ever sustainable to use virgin trees for bioenergy? Probably alluded to that a bit.
Our position as a trade association in Canada is that it is not acceptable to use whole trees unless they are like when you go harvest the trees, or a forest, there's big and small. Some trees have been eaten by insects or blown down by wind and are rotting, maybe you can't make lumber out of those. But the large-scale purposeful harvesting of roundwood to turn into wood pellets, we do not support that.
Thank you for addressing that. I think we'll get into the next topic because I love innovation. And I think it's quite pertinent to get this message across in terms of what the Net Zero Innovation Portfolio projects have achieved, what they've done to propel, I guess, the BECCS for an acronym term, bioenergy with carbon capture and storage. I'll get to, there's another question in here referring to biochar and priorities as well.
Actually.
So we'll address that one as well. So the first question. So in terms of the development, innovations and technologies that have shown, I guess, to achieve net zero and facilitate decarbonisation of the industries, especially hard-to-abate sectors, could you elaborate further on the projects thus far and the progress and how they've achieved that?
And I'd also like to reflect on your previous question a little bit about increasing the sustainable supply in the UK. Yeah. So, for us in the UK anyway. So under the Net Zero Innovation Portfolio, we've got this biomass feedstocks program. It's quite an unusual one for Department of Energy Security Net Zero to be running that kind of project rather than DEFRA. And the point is that obviously it is a feedstock rather than something that we are just growing. But we've been doing some really exciting things in that area, and some really great innovations are coming through. So, for example, we're doing genomic selection. So we might be looking at perennial crops or short rotation forestry in willow and miscanthus, for example. There are two headings, but there are loads of different varieties. So choosing the ones that are absolutely right for the UK, trialling them across the UK. So we've got the different climates, we've got the different soil types. We're looking for that greater yield specific for energy or actually for other end uses. So those are part of the areas that we're already exploring and demonstrating them over a decent period of time so we can get some really good data and feed that back into this particular industry. And I think that's, starting, I was going to say at the ground up or grassroots, both bad puns, but starting right at the beginning there in that sort of raw material sourcing, I think is a really crucial part of this biomass journey. And particularly when we're looking at things that are coppice, they're not cutting down the trees necessarily, or in the sustainably managed forest, that obviously has a really key part to play. But we've got both ends of the spectrum here, with hemp being like an annual crop and the longer duration ones in the forestry, and we've got these other crops in between. I think they all have a really important part to play. But then if I take you on to the next stage where it moves into energy, do you say BECCS on that specifically?
Yeah, so how will developments and I guess innovation propel that net zero path to net zero?
So obviously taking that biomass, converting it onto so it has its part to play in that net zero innovation or net zero role. We are looking at the conversion of technologies, particularly in the program that I'm running, in hydrogen. So it's, what sources of biomass can be used for that? We do have wood pellets coming through directly on that, and how they might be gasified, and then how that carbon, so you're taking the hydrogen, you're splitting it, you've got a hydrocarbon, you're taking that carbon, and whether it's carbon dioxide for sequestration or whether it's biochar, as I saw on one of those questions, these are all really core opportunities there. we're not just looking at primary biomass, though. You know, we've got 67 million people in this country. We've got quite a lot of sewage sludge coming through. We've got quite a lot of food waste coming through. These are also really useful sources of biomass. They're really useful hydrocarbons that we can still make hydrogen out of. We can make biomethane out of, and we have been for many years. And we can, again, I'll use an example. We've got United Utilities, one of the big wastewater companies in the Northwest, is working with a company called Levidian. They are separating the hydrogen out, and then that carbon, instead of carbon dioxide, they're making graphene. So a really useful product. It's got great conductive properties. It's great. Well, it's got numerous opportunities, but still quite fledgling. Yes, so that's a really exciting opportunity in the innovation space. And we have another group of people that are working in that pyrolysis one, and again creating hydrogen. Short pipeline to a logistics company, and then we've got the carbon again through biochar that can go back to land or can be buried. And I suddenly realized I could probably wax lyrical and use the rest of the time on that, so I'll pass on to some of the other panelists there.
Yeah, if you have anything to add.
Sorry, you have to
yes,
give me a bit of parameters.
So, I mean, in terms of, I guess, elaborating on, I think one of the questions here I want to address is, yeah, the main one, how can we better balance bioenergy production with food security going forward? I think that's probably the pertinent message we need to get across today.
Yeah, it's always going to be a very difficult challenge, not only because, to be honest, biomass supply, food supplies are very difficult to pin down in a reliable fashion over a long-term basis. I think it is about, improving or should we say, putting those mechanisms in place whereby farmers and all the other stakeholders in that supply chain can be incentivized to find uses for waste. That's the sort of bioenergy component. The reality is that there are very few crops out there that don't have some residual material, particularly food crops. So yeah, it's about sort of what mechanisms can we put in place to help connect the dots between where that material is produced and, where it can be better utilized. And that really comes through incentivization. Change only really comes along at it moves at the speed of money. So I think it's a case of incentivizing people to connect those dots and ensure that, things are used in the best possible way. Ultimately, food is really the priority. It's the most important thing that we can produce. I think what we've seen with sort of, the biomass strategy document and new initiatives coming from the government, such as ELMS, is, an effort to sort of balance things out and ensure that all of these different categories and needs of our economy and our society are being met, but it's going to take time to be able to do things in the most effective way possible. So I think more engagement between government and stakeholders across the supply chain, communication and incentivization are the critical pieces as far as I can see.
It's that cross-sector collaboration.
Correct, yeah.
And Gordon, from an international perspective and from a Canadian perspective.
I mean, the food versus fuel debate, it usually boils down to land use. So in forests, we don't generally contribute to the food versus fuel because we're not converting agricultural land into forest land. Our forest land is fixed, and so when it comes to agricultural land, it's the debate about whether that land should be used for food production or it should be used for bioenergy production. And generally speaking, society demands that the more fertile and productive lands should be used for food. The lower productive that are not capable for agriculture should be used for biomass feedstocks or for agricultural biomass feedstocks. And then if the primary land is being used, then it should only be the residues that are collected. And that's somewhat challenging using the residues to create the energy, where if you look at ethanol and so on, the first generation was based on oilseed crops and so on, or sugars, which are harder to get from the residues. but it's the food versus, or it's the land use and making sure that we manage our land appropriately.
Resource management.
I'd really reiterate what you're saying. We have the same view in the UK that primary land has to go to the agricultural, but we've got quite a lot of marginal land. How can we use that, balance it with the biodiversity that comes in by having crops like short rotation forestry, the willows and such like. But it's completely about balance, isn't it? We've got a lot of demand going on.
And well, back onto innovation, really. I think one of the questions are very similar to what I answered, or I'm about to ask. What are the most promising technologies you've encountered while overseeing the NZIP portfolio? And how will those projects afford the sector the greatest opportunities? So just on that similar tangent, an audience member has asked, are there any emerging technologies or projects that will support the UK biomass or BECCS strategy?
Oh my goodness, absolutely. We're really focused on the BECCS because, as I said, the unique selling proposition of bioenergy in the net zero story is that carbon capture element. So whether it's being captured as carbon dioxide or whether it's being captured as solid carbon, and they both have a really important place to play, that is where we are spacing that. So I've already mentioned that United Utilities project is one. We have another project with CPL, so Coal Products Limited, who recently rebranded to Invica up in the northeast. They are using digestate from anaerobic digestion. Notoriously, I come from the AD industry, so notoriously bad for having microplastics in the digestate spreading to land. And believe me, because I've spent so many hours of my life trying to minimize those plastics, when I saw this technology, I was blown away. It's so obvious, but I didn't know it. So pyrolysing that, you're taking that plastics, you've got the energy, you've got it's kind of a circular process there, and then you're creating biochar, which can go back to land in a really stable form. It's enhancing the land, and it's basically carbon capture, because so long as it's not reacting or being released, that's your solid carbon going back. There's another one that's in that carbon capture space with biochar. And again, really simple technology. This is a company called Lapwing. They are an organic farm in North Nottinghamshire, so close where I actually live. It's old coal fields area, really. And what they are doing is, again, creating biochar using the pyrolyzed power, so the heat and power across the farming land, the farm production processes, but then they're burying. So instead of spreading it to land, they're literally burying the biochar in this peatland. They're covering it with peat again, and they're re-wetting it. So these areas have been drained for a long time. It's one of the biggest sources of CO2 from agriculture. What they're doing is rehabilitating that peatland. They are growing willow on it again, which gives a really good natural biodiverse habitat, but they're able to reuse that willow as for that generation of biochar. So it's that really big circular process, which is great. And then I guess in other areas, in the more large industrial format, we've got a number of gasification technologies. So it's biomass, gasify, create hydrogen. And then there's a multitude of different technologies for the carbon capture. And one I really like is a cryogenic one. So it's getting rid of the amines, reducing the chemical demand, reducing capex, reducing opex. And that has to be the next level we go on our bioenergy, is how can we make it more financially susustainable, as well as all the other challenges it has on its sustainability.
That's what no one's been sliding into a Slido, my Slido at the minute.
Sorry.
Please feel free to ask them further questions, and just to elaborate on what stands in the way of commercializing these technologies.
To a certain extent, the social license. And also, we don't have a massive amount of biomass being generated in the UK. I know we have some good stats there, but there's a huge conflicting priorities there. But what we found, and this is something I personally want to try and help unlock as much as I possibly can, is actually bringing the value chain together. So I have growers who want to grow, but getting those long-term contracts so that they are, directing towards an energy source or a long-term consumption, because it takes a while, whether it's a forest that's growing or whether it's even willow that's growing, that's got a 5-year till its first crop, and miscanthus. You really want to be looking at 20-year life cycles. So being able to connect the growers with those consumers and have that pull through on that financial security is a really, really core point that we've had coming through.
How would you incentivize that?
I think so we've got several business models that have come out in the greenhouse gas arena and the CCUS arena and the hydrogen. So those are kind of the 3 draws. They are designed to give long-term financial security to those end carbon capture components, and that hopefully that will flow down to the rest of the supply chain. So we've had greenhouse gas removals in the latest round of the CCUS clusters. I don't know if people know that. That's 2 areas within the UK where we're prioritising the carbon capture for geological sequestration. And they also obviously have had the CCUS for a long time, for the last few years in those areas. So hopefully that's got that draw through for them, and that's connecting those suppliers on the biomass feedstock side of things. And in the hydrogen allocation round that came out at the end of last year as well, for the first time we had biohydrogen. So recognising that innovation in this area is at a sufficient maturity now for biohydrogen to be playing on that and to have those long-term contracts. They're contracts for difference where the UK government basically underpins the price. And that should again help to draw through the use of the biomass there.
Thank you. Now we're on to audience questions, the final 10 minutes. So a question from Ben Aslan. You speak of turning waste into energy, but is there any agricultural waste, interesting, that could also be composted and produce fertile soil? Any agricultural waste residues that we could be composted or produce more fertile soil?
So is there a better use case for it in terms of composting instead of turning it into energy?
Is Ben in the audience?
I'm sure.
Yes. Could you stand? I don't know. Could you elaborate further? Could you shout, please?
I can't hear that.
Yeah, I wish I was better at lip reading, and one of my ears is locked up. But if I'll give it a go. I think with regards to agricultural residuals, and I heard you say forest as well. So sorry if I don't, deal with the whole question. But there are certain crops that produce so much biomass. For example, hemp. The reality is that we've got an annual crop where we drill the seed in May. We produce anything from minimum 5 tons up to 15 tons of biomass on a per hectare basis. So trying to mulch that and put it back in the soil would just be a non-starter. What happens or what has happened in other locations, and in fact, the reason why we as a business really focused on opening new markets for hemp is that we encountered various hemp farms around the world that were having to burn the residual material in the middle of the field in a number of locations, even ones that are really advanced, such as Canada. And that was something that was, on a very small scale, but that was just the practical problem that had to be overcome. So I think, with certain crops, they don't produce a lot of material. With others, there's just way too much to be composting, and you really have to find a better outcome than burning it in a field. And in those particular circumstances, waste to energy is absolutely the right course of action.
I wonder if we're overlooking, all across Europe, anaerobic digestion is quite well known. So the agricultural crops are gathered and put into a reactor in low oxygen or no oxygen environment. And then you generate a gas, a syngas, and that syngas is cleaned and then it can either be turned into methane and put into the natural gas grid, or in many cases you can hook like a diesel type engine, but it runs on syngas instead of on diesel,
Yeah.
and then you turn that to create electricity. You could capture the heat off that and use that for district heating. We see these all over Europe, and then the spent digestate at the bottom of the reactor is used for fertilizer in farmers' fields. These are very common all over Europe. I'm not too sure about the UK.
We have a
To a
lot here
degree,
too,
yeah,
yeah.
They do exist in the UK. I don't
Yeah.
think we don't have the same systems in place as what you encounter in Germany with the infrastructure
Yeah.
they have, the AD, as well as the district heating systems that are
Yes.
so efficient. But I think beyond just taking a wasted resource and turning it into energy, it's important to take into account the commercial upside of being able to use material like that, because one thing we encountered as an early stage business is that establishing a new supply chain, scaling a new supply chain, a lot of it just came down to the unit economics stacking up and making sense, and the farmer ensuring that they get the right sort of margin to want to keep growing our crop. So the beautiful thing about bioenergy is that what you have with AD digesters or even buyers of pellets and CHP facilities is that they're in a position where they do want to offer those long-term contracts, because power stations here, generators of electricity, they get penalized for not generating electricity. For them, what they prize above all things is price and reliability of feedstock. So being able to deploy those resources, those waste residuals into fairly low margin outcomes, but ones that can be underpinned by long-term contracts, is going to be really vital to ensuring that the step changes that need to happen actually do happen, are in place for the long term.
Can I just add in one little innovation on that?
Yeah, of course, yeah.
This is just a kind of a sideline one. This is a really curious one I found. So we've got one project that's looking at harvesting heather from moorlands. They were previously burned off, which obviously we don't want to be doing anymore. So look at how can we manage to harvest that heather whilst maintaining the moorland in a really good way. And they found that this heather actually makes an excellent compost. So it's going for that really high-end composting, and it had too much ash to be used for energy. So actually in that particular case, that crop has gone to compost.
So we have 3 minutes left, and I know that there's a few questions here, but I want to end on this session on a positive and what the future outlook. I know most of the questions will be for Charlie. So any of the audience members that did ask those questions, are you happy for any audience members to come approach you at the end?
Yeah, for sure, yeah.
So yeah, so just to end on a positive, what's the future outlook for this sector, and yeah, what are the opportunities? I guess a minute each.
I think this sector is really exciting. There's so many opportunities, but I think the financial value of it really comes in having multiple products from biomass. So the energy is one direction of travel, but when you can generate chemicals or generate plastics or any sort of multi product opportunity from it, that's when the biomass absolutely shines, because it offers so much in this net zero transition.
Gordon?
When you look at the UK bioenergy strategy, I think in my mind correctly identify bioenergy, carbon capture and storage as the biggest opportunity. And you can see right over here at the front of the pavilion, you've got the Humber group there and all those different companies that are involved in that. That will be massive. And for my sector, wood pellets they're dense, homogeneous, dry, ideal feedstock that can be used for more than just making electricity. We're also looking at sustainable aviation fuel, at biorefining, at hydrogen, and so on. The opportunities are endless, but the key is to do it sustainably.
Amazing. Final minute, Jamie, on hemp.
So, I think bioenergy sector, the UK's plans, everything is, falling into place. What I would say, very much focused on hemp, is that there is tremendous opportunity with this crop. Myself and my team, we've been developing and de-risking a business model that can be dropped into any number of locations to deliver food, construction materials, and bioenergy solutions, all in tandem. And, you know, we feel that there's a lot of exciting technologies in the pipeline, and this happens to be one that's actually ready to go today, that can start having impact within the next 12, 24 months, not just in terms of developing products for bioenergy, but also carbon dioxide removal. You know, we're sort of at a bit of a tipping point with hemp. We've been doing the proof of concept across a range of different locations. And, you know, we're very excited about being able to have impact quickly and are on the lookout for the right types of backers and partners to be part of this journey. So if anyone wants to have a chat afterwards, please do grab me.
Yes. And that ends the session. Thank you so much for attending. Really appreciate your time.
Thank you for listening.
Well done. Thank you.